So when you expand the series, you will get 1 by 8 into then minus 1 plus summation r equal to 0 to infinity 4x whole power r by r factorial plus summation r equal to 0 to infinity 2x power r by r factorial minus summation minus 2x whole power r by r factorial. So therefore, the value of AR will be 1 by 8. We need the coefficient of x raised to r. So that will be 1 by 8 4 power r by r factorial plus 2 power r by r factorial minus 2 whole power r by, sorry, we don't require r factorial for the exponential generating function. We need the coefficient of x power r by r factorial, that is AR. So this is the required value of AR. Now let us look at one more similar problem. So find AR, the number of ways of distributing R distinct objects into n distinct boxes such that no box is empty. So there are a total of n distinct boxes and we need to distribute R distinct objects. So no box must be empty. So when you write the generating function, അപ്പോൾ e raised to x വരില്ല, e raised to x നമ്മൾ എഴുതുന്ന കേസിൽ the case where the number of objects is 0 is also taken. So നമ്മുടെ terms are x plus x square by 2 factorial plus x cube by 3 factorial plus etc. will come, and for each place, okay, for each distinct box, that will be the term in the exponential generating function. So whole power n there. Okay. So the exponential generating function of AR, that will be equal to x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. whole power n. So that is e raised to x minus 1 whole raised to n. So this will be in the form of binomial expansion. So this is summation r equal to 0 to n. Okay, let me not use r. Let me take I. It is from 0 to n. So this is nci e raised to x power n minus I into minus 1 whole power I varum. Now let me write the expansion of e raised to x. So I equal to 0 to n nci, this can be written as e raised to n minus I x minus 1 whole power I. So that is summation 0 to n nci minus 1 whole power I varum, and this will be summation r equal to 0 to infinity n minus I whole power r x power r by r factorial. Now we can now take the coefficient of x power r by r factorial. So this can be rewritten as summation r equal to 0 to infinity summation I equal to 0 to n minus 1 whole power I nci into n minus I whole power r into x power r by r factorial. Now this will be the value of AR. So AR will be equal to summation I equal to 0 to n minus 1 whole power I nci n minus I whole power r. And you have seen this sum before. So this is equal to f of Rn. So this is the number of surjective mappings from Nr to Nn. So which is the number of surjective mappings from Nr to Nn. So number of surjective mappings ചെയ്തപ്പോൾ കണ്ടതാണ്. So that is the number of ways of distributing R distinct objects to R identical boxes. So that will give the number of surjective mappings from Nr to Nn. So this is an example of obtaining the number of distributions using the generating function. Now let us classify all these types of distribution problems. അപ്പോൾ നമ്മൾ മോഡ്യൂൾ 1 തുടങ്ങി distribution problems നമ്മൾ കാണുകയാണ്. അപ്പോൾ distribution problems mainly they are classified into 4 types. So you can have objects and boxes. So this can be identical and this can be identical, then identical and distinct, then distinct and identical, then you can have distinct and distinct. So there are identical objects can be distributed to identical boxes and identical objects can be distributed to distinct boxes, then distinct objects can be distributed to identical objects and distinct objects can be distributed to distinct objects. So these are the 4 types of distribution problems we have seen. So let us write down the classification and in each case the concept and we use it. Distribution problems can be classified into 4 types according to whether the objects to be distributed they are identical or distinct, and the boxes can also be identical or distinct. So these are the 4 different classifications. അപ്പോൾ നമ്മൾ R objects and N boxes ആണ് എടുത്ത്. Both can be distinct, then objects can be identical, boxes can be distinct, then objects can be distinct, boxes can be identical, and both can be identical. So in the first case, when you are distributing distinct objects to N boxes, അത് നമ്മൾ first module കണ്ടതാണ്. The first object can go to any of the N boxes. അതുപോലെ രണ്ടാമത്തെ object എടുക്കുമ്പോഴും that can be put into any of the N boxes. So on the rth object can be put into any of the N boxes. So we'll have N raised to R. Then the number of ways of distributing identical objects to distinct boxes. This was the problem of finding the number of non-negative integer solutions. So നമ്മൾ x1 plus x2 plus xr equal to n ന്റെ solution ആയിരിക്കും problem എന്ന് പറയുന്നത്. So number of non-negative solutions of that problem. So that was given by n plus r minus 1 cr, which again we have seen in the first module. The problem is the number of ways of distributing R objects to n identical boxes. So which is what we have defined in the Stirling's number of second kind. So the number of such distributions will be S of summation of S of R1. So the number of boxes can be from 1 to n. And the last case was the number of ways of distributing identical objects to identical boxes. അപ്പോൾ ഇത് നമ്മൾ partition of integers ന്റെ അകത്ത് കണ്ടത് ഇതാണ്. നമ്മൾ partition അകത്ത് മെൻഷൻ ചെയ്തിട്ടുണ്ട്. So that was the number of ways of distributing R objects to n boxes. അപ്പോൾ when you find the partition എപ്പോഴും n boxes അതിൽ താഴെയുള്ള boxes ആയിരിക്കും നമ്മൾ partition അകത്ത് കണ്ടുപിടിക്കുന്നു. So these are the different types of distribution problems. These are the classification of the distribution problems. So with this we will conclude the section on generating functions and in the next class we will begin recurrence relations. We will see how to solve for linear recurrence relations, and we will see a few classic examples of recurrence relations.